So today we're actually going to get started on exponents. Well, let's say if you had a to the nth power, that n up there. Hello, 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 everyone. That n is your exponent. Okay. So all that tells us how many times you're going to multiply a times a times a times a. So a to the nth power is just a times a times a times a, and it's going to keep on going n number of times. Okay. Now this is called an exponential expression. Now your a, this is actually called your base. And your exponent is n. Now to put this in actual numbers, let's say if we wanted to evaluate the following. Okay, so let's say for problem A, wanted 2 to the third power. Problem B, you have 3 to the first power. For problem C, so you had -4 to the second power.
Why is that one in parentheses? Because it's negative?
Yep, actually there's two versions of this, and we're going to do both, where you have the parentheses and not the parentheses. We're going to cover both of those. Okay. Now D is just the same thing, but without the parentheses. And we'll see the difference between those two. And E, let's say 1/2 to the fourth power.
Is there a reason you're putting that in parentheses?
Yep, because you want that to apply to the whole thing.
Okay.
Yep. And that's what the parentheses does. It tells you that that exponent applies to the whole thing. That's kind of where those two are going to come in. Okay. Now for A, 2 to the third power is just 2 times 2 times 2. You're just multiplying 2 3 times. 2 times 2 is 4. 4 times 2 is 6. I mean 8. Sorry about that. I'm adding. There you go. So we end up with 8. Okay. Now we have something to the first power. It's just that number. It doesn't change at all. So 3 to the first power, you're just multiplying 3 once. So that's just 3. Now C and D is where most of the mistakes happen because of those parentheses that can make those a little bit tricky. So for C, you have -4 squared with the parentheses, the negatives in the parentheses. So that just means that square applies to everything in there. So that's just -4 times -4. Yep, which is +16. Nope, why did I put B up there twice? That should be D. Okay. Now for D, if you have -4, you kind of separate these two a little bit. If you have -4 squared, then that means that squared only applies to that 4. It doesn't apply to the negative. So really, this is the same way as saying -1 times 4 squared. Which is like saying -1 times 4 times 4. Okay, so we know 4 times 4 is just 16. So it's -1 times 16, or just -16. Yes.
So, but that would always be negative if it doesn't have parentheses.
Yep, that negative just kind of lingers on the outside. This is kind of the long, stretched out version of it.
Yeah, without the parentheses, you're basically just doing the problem without the negative on it.
Yep, exactly. Now, it all depends on what this is. If you have 3, then you have -4 times -4 times -4, your answer will come out to be negative. But if you have -4 times -4, because the negatives cancel out, it'll come out to be positive.
Oh yeah, you're saying like if you have an odd number.
Yep, exactly.
Yeah. For the exponent.
Yep, because if you have those parentheses and an odd exponent, it'll come out to be negative. All right, so that's kind of the difference between the parentheses and not parentheses. And for E, if you have 1/2 to the 4th power, that's just 1/2 times 1/2 times 1/2 times 1/2. And remember, when you're multiplying fractions, you just multiply the numerators, then you multiply the denominators. So you have 1 times 1 times 1 times 1, which is just 1. And 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Yes.
There's another equation where you can simplify and you simplify, would it be wrong?
I mean, if you had another one, you could simplify. Oh, you mean if you had maybe 2/3 to the 4th power or something like that? Oh, yeah, if you could simplify it at the end of it, then yeah. So let's say if you had, I'm trying to see if that would simplify. Leave that up for a few more seconds. If anyone's still writing. Looks like everyone's done writing. Uh-oh. So what if we had 2/3? Actually, I don't think this one would simplify. Yeah.
The second power?
Let's say to the 4th power. Pretty sure this one probably won't simplify into anything else, but we'll do it anyway. Okay, so if you have 2/3 to the 4th power, that's just 2/3 times 2/3 times 2/3 times 2/3. Now, normally, if it could simplify, you'd be able to simplify it here before you do that. Okay, so you have 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Over 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. Yes.
Okay, for example, you got 4/8, you simplify before you do the steps. Like get 4/8, you do 1/2.
Oh yeah, if you simplified beforehand, that's when you would want to do it, because then your numbers won't grow as fast. So if you simplify it, it would happen probably at this step. All right. Any other questions on this one?
Don't simplify the fraction?
Hmm?
Oh, you can't, never mind.
All right. Leave that up for a second. Oh, should have plenty of room to finish up on this one. So let's say, for example, we wanted to evaluate 2x to the third power when x is equal to 5. Okay. Now we know that when x is equal to 5, our 2x to the third power just becomes 2 times 5 to the third power. You can use the parentheses or you can use the multiplication dot. Either one of those will work. Okay. So we know 5 to the third power is just 5 times 5 times 5. So that's 2 times 5 times 5 times 5. Okay. Or we have 2, because we know that 5 times 5 is 25, and 25 times 5 is 125. So those three is 2 times 125, or 250. Now you could do it that way, or you could have done 2 times 5 is 10, 5 times 5 is 25, 10 times 25 is 250. You can do it whichever order you want. Okay. Any questions on that one?
Were you saying earlier that if the exponent is with a negative number, if it's an even exponent, it'll be, if it was a negative number to begin with, it would be a positive number?
Yeah.
If it's a opposite, or I'm sorry, if it's a, not an odd number, it'll be negative.
Yep, it would be
It'll just
negative.
float to the end.
Yep, exactly. It'll
Okay.
just keep on going. Actually, we can do this one, but we'll make that with -5. So what if we wanted to evaluate 2x to the third when x equals -5? Yep, so everything else is exactly the same as up here. The only difference is instead of 5, it's going to be -5 everywhere. Okay, so when x is equal to -5, then that's when your 2x to the third power is equal to 2. That's when you have to have the parentheses, whenever you have that negative in there. 2 times -5 to the third power. Because if you didn't have the parentheses, it would just look like 2 minus 5 to the third, which would throw you all off and confuse you. So you want to use the parentheses there. Okay, so really that's just 2 times -5 times -5 times -5. That's our -5 to the third power. Okay, so if we did have -5 times -5 times -5, remember -5 times -5 is positive 25. So you'd have 25 times -5, which would end up being -125. We'll put that underneath it. So you have -125. Okay, so you have here 2, and you multiply those 3, it'd be times 125. Well, in this case, it would be negative 250. So whenever you multiply with the negatives, it's usually safer to make sure it's in parentheses, because that parentheses makes sure the entire negative and everything gets multiplied. Okay. Any questions on either one of those?
Can I just go straight across? Like, can I do 2 times 5 times 5 times 5?
Oh yeah, you could have done it that way. 2 times negative 5 is negative 10. Negative 10 times negative 5, positive 50. Positive 50 times negative 5 is negative 225. I mean 250. So
Okay.
you can just go right across, or you can bounce around. Either one works. Right. Simply just a matter of which one you're most comfortable with. Okay, so let's see. Let me pick a good one. Let's we'll start with the rules of exponents. Anyone's still writing? Looks like everyone's done. Now we get into our rules for exponents. Okay, now the first rule is our product rule.
Wednesday closed for next week.
Okay, product rule just states that x to the power of m times x to the power of n equals x to the m plus n. So as long as you have the same base and you're multiplying them together, it's going to be x to the m plus n. Okay. Now, kind of the drawn out reason for that, let's say if you, this is all you're really going to have to remember. Let's say if you notice, if you have x to the second power times x to the fifth power. Uh-oh. Clean that up a little. Okay. Now, if we wanted to stretch those out, our x to the second power is just x times x. And that's times our x to the fifth power is just x times x times x times x times x. So if you add those all together, it's just x to the 1, 2, 3, 4, 5, 6, 7. X to the seventh power. Okay. Which works unless you have one that says, let's say, if you wanted to simplify, x to the 20th power times x to the 18th power. Are you really going to multiply x 20 times and then another 18 times and then add them all together? You don't really have to. Because x to the m times x to the n, as long as those bases are the same, you can just add your exponents. So x to the 20th power times x to the 18th power is just x to the 20 plus 18. So that's x to the 38th power. So it doesn't matter how big those are, you just add those exponents together as long as your bases are the same.
Is there another rule for when the bases aren't the same?
Yep, it just stays like that.
Okay.
Yep, so if you had, say, simplify say x to the 25th power times y to the 48th power. The bases are different, so it just stays like that. Okay. Are different. Uh-oh. So you cannot combine them. Uh-oh, clean that E up a little. Okay. So your simplified answer for this one is just x to the 25th times y to the 48th. Since you can't do anything else with it. All right. Any questions on that one? All right. Leave that up for a second. Right, so let's say, for example, we wanted to simplify, say, 5 to the 4th power times 5 to the 7th power. And write as an exponent. So sometimes they want you to solve it, sometimes they just want you to rewrite it as an exponent. Okay. So we have 5 to the 4th power times 5 to the 7th power. Now the first thing you notice that your bases are the same. Okay. So as long as you have the same base, it's just 5 to the 4 plus 7, which is 5 to the 11th power. Okay, so, just a quick reminder that you don't have to multiply the bases. I've seen people multiply and make that 25 to the 11th power. You don't want to do that. If the bases are the same, then it just stays the same all the way through. Do not have to multiply the bases. Okay. So if you have something like 3 to the 3rd power times 3 to the 6th power, it's not going to equal 9 to the 9th power or something like that. Okay. So if those bases are the same, your answer is just going to be the same base. So 3 to the 3rd times 3 to the 6th is going to equal 3 to the 9th power. Oh, do you have a question or just?
What if they're different? Did you add them and then add the exponents?
Oh, if they're different, then you couldn't combine them.
You could?
Nope, you couldn't.
Oh, you can.
Yep, so if you had, let's say, 7 to the 5th power times 8 to the 3rd power, you couldn't combine those at all. It would just stay like that. So that cannot be simplified. Since the bases are different. Yes.
We would have questions when we, like, do a 7 to the 5th exponent. Do we have to solve it?
Most of those, they would just want you to simplify it, like just with that exponent.
I was saying, if it asks us to multiply, do we, when we finish?
They probably, well, they shouldn't, at least not for like really big numbers. But on Newton, they're kind of known to throw big numbers at you, so. But on the exam, it won't be anything too big.
Yeah, I'm saying, like, even when you solve it, do you add it when you're done or multiply it?
Oh, when you're solving it, you just multiply it. So if you were just going to solve it, then it would be 7 times 7 times 7 times 7 times 7 times 8 times 8 times 8, and then it's some huge number. So.
Is the homework gonna be huge numbers like that?
It might be. Newton has been known to throw some pretty big numbers. So. All right. Any other questions on this one? All right. Oh, one other thing. When there is no exponent, you're going to assume it's 1. So you assume it has an exponent of 1. Okay. Bless you. Let's say, for example, if we wanted to simplify, let's say 12 to the 5th power times 12. Okay. So when there's no exponent, we know that 12 is just 12 to the 1st power. So that means this, 12 to the 5th power times 12, is just 12 to the 5th power times 12 to the 1st power. So even when there's no exponent, there's an exponent. It just happens to be 1. Okay. Again, you have the same base, so you can combine them. So that's 12 to the 5 plus 1, which is 12 to the 6th power. Okay. Now, I didn't want you to solve it, just simplify it. All right. Any questions on that one? All right. Did I do the quotient rule or did I put those notes? All right. Okay, so the next one, anyone still writing?